What up, ladies and gentlemen? We are moving on with our unit. This is Unit 2. We are looking at velocity versus time graphs. In class, I gave you this very simple position versus time graph, and I asked you to create the velocity versus time graph. If you have not tried it, this is where I'd say just give it a pause and give it a shot real quick. So, if I was looking at this graph, the first thing that I would realize is there are numbers on this graph, and the next thing that I'm going to realize is the slope of this graph is velocity. So, in other words, what I want to do is I want to calculate the slope, and if you look at rise over run, we have 5 meters over 5 seconds, and you're going to get a 1 meter per second slope. The next thing, and this is the most important thing to understand about this graph, is that the slope of this line is constant, aka the slope of the velocity is constant. So when I talk about a constant velocity, it means the velocity value is staying the same for this whole entire time. So if I were to go to the velocity versus time graph, what I'm going to be doing here, is that I'm going to be thinking that for the first second, second, third, fourth, and fifth, I have the same velocity value. So in other words, at the beginning, 0 seconds, I'm actually at my 1 meter per second velocity. Note how I've made this a positive, because it is a positive velocity, a positive slope. And so in this case, throughout this whole entire time frame, I am sitting at a 1 meter per second velocity. So this starts to get a little bit confusing, but as long as you remember that the slope is constant of this line, you can get the idea that the velocity must be constant. And on any graph, just think about a velocity versus time graph, that value must not change. And you'll notice that that stays 1 meter per second for every one of those time frames. If that did not make sense, please listen to that again. That is a very important piece. So, things that I would say are key ideas when creating a velocity versus time graph. Remember, number one, the slope of the position versus time graph is velocity. So that's the key idea. You look at the position versus time, and you get velocity from that. Time is what links both the graphs together. We're going to see this in the next example, and this is really helpful when you have different velocities within your graph. And last but not least, when I think of a V versus T graph, first off, I want to make sure that this first point right at the t-axis, what just happened? Hold on. Let me draw that back in there. I don't know why it erased. Let's try it again. So, right at the t-axis here, this is actually when the object is stopped. This is aka 0 meters per second. So if I draw a dot anywhere on this t-axis, what I'm basically saying is this object is stopped. Right after stopped, remember this is slow velocities and this is fast velocities. So as you get further up the axis, we're getting faster and faster. And on over here, this is also slow, and this is also fast, but you notice all what that is this is just different directions. This is moving to the right, and this is moving to the left. So that is how you read a velocity versus time graph. Again, fast, slow, stop, slow, fast. Keeping in mind this t-axis is the kind of the key that is when an object has stopped. So using that, what I want to do is not go to this page. I want to go on over here to a second example, and what I want to do is looking at this position versus time graph, I want to create the velocity versus time graph that looks at this. So again, pause it real quick, try it out for yourself. You'll notice that there are no numbers here. What I want you to do is I just want you to use that idea of slow and fast in order to do this. So pause it, give it a shot real quick. Alright, so if I were looking at this, the first thing that I want to be thinking about is, again, the slope is the velocity. So I'm thinking that this line right here, this is fast, and this is positive. So that's a very fast car, or fast part of the piece, and it's going to be positive velocity. Then I look on over here and I say that's slow, and that is negative velocities within that. And then the next big piece about this is I want to link these two things together through time. So at this mark, this 1 second refers to the 1 second down here. This 2 seconds refers to the second down here. So you'll start to notice when we start drawing these, we're going to actually line these up one over the other one. So in this case, you will see that these are lined up like that. And so what I want to do is I want to start off with a very fast positive velocity. Remember that the slope is constant for the first 4 seconds. So the velocity must be constant for the first 4 seconds. So a constant positive fast velocity will look like a horizontal line. Remember, same value for all 4 of those seconds. And then for 5, 6, and 7, you're going to realize that we'll have a slow negative velocity, which will look something like that. Those should be horizontal lines. My apologies if they don't look horizontal. The other thing that I want to talk about is what's happening at 4 seconds. And the question is, what is the slope at 4 seconds? And you're going to realize that that is a break in the graph. There technically is no slope there. The velocity is undefined at that point. So what we're going to do is we're just going to leave it. We're just going to keep that a dotted line. Don't worry about doing open circles, closed circles. I don't really care about that. We just know that there is no velocity at that point. So this is a quick review, or the quick overview of velocity versus time graphs. We will get more practice on this tomorrow and into Friday. Any questions, please bring them to class. Thank you.